Hey guys, today we are going to be doing Unit 6, Day 1, the Pythagorean Theorem. Before we start that, we're going to do our warm-up for the day, which is going to be a proof. So let me go back to my document camera. Alright, so for our proof, it says prove these two triangles are congruent. Our given information is always your very first step. So I'm going to put my conclusions here and my justifications here, because I prefer to do like a two-column proof. Alright, so my given information is angle C is congruent to angle D, and AC side is congruent to A side AD. And for our justification, anytime we write down all the given information, our justification then is given. Let me move that out the way. Alright. They want me to prove the two triangles congruent. So since we have overlapping triangles, I like to highlight the triangles in different colors so I can see where my triangles are at. And I can also see then what they're sharing. So they told, and I also like to, once I highlight them, I like to draw them separately. So there's triangle ACE, and that's drawn separately already for you. The other triangle is ADB. Alright, so I've got my two triangles drawn. They're separated. Now I want to label what was on my given information. Angle C congruent to angle D, and side AC congruent to side AD. Alright, so that's all I can really pull out of my given information. They didn't give me any clues saying anything was a perpendicular or bisector or midpoint or parallel. So they've only told me that this is congruent to this and this is congruent to this. So I can't really pull anything else from the given, but from our diagram, since they're overlapping triangles, we can see that they're sharing something. In this case, for both triangles, they share angle A. So I can make that statement that angle A is congruent to angle A. And since it is the exact same angle, then it's saying the exact same things are congruent to each other, and then in that case, our justification is reflexive property. So now I have enough information to prove the two triangles congruent, and since what we are trying to do is prove the two triangles congruent, that's going to be my last step. Triangle ACE is congruent to triangle ADB. And the reason I know they're congruent is by angle, side, angle. And then I'm done. There's my proof. Step one is always the given, and then your last step is always the prove. So I've proven them congruent, so we are finished. Okay, for our notes today, we're going to be covering the Pythagorean Theorem. Oops, un momento. So our objective today is to use the Pythagorean Theorem in order to find missing side lengths of triangles, diameters in circles, and diagonals in squares and rectangles. So in your notes packet, we've got some notes to fill out. So triangle and Pythagorean Theorem notes. The Pythagorean Theorem comes from the Greek mathematician Pythagoras, and he came up with the following. In a right triangle, the sum of the legs squared is equal to the hypotenuse squared. And the way, excuse me, so remember your hypotenuse is always across or opposite your 90-degree angle. So they're saying if I add up this leg squared and that leg squared, it'll equal that side squared. So remember, that's your hypotenuse, and it's always a good idea to draw your arrow, label which side is your hypotenuse and which ones are your legs. So let's make sense of where this theorem came from. What is the small area of the smallest square? Remember, area is just length times width, or a side squared, and when you're talking about a square. So the smallest square is this one here, and it looks like it's 3 units by 3 units. So we would find that area by 3 times 3, or 3 squared. which gives me 9. What is the area of the bottom square? The bottom square is 4 units by 4 units, so that's 4 times 4, or 4 squared, which is 16. And then the area of the largest square is 5 units by 5 units, so 5 times 5, or 5 squared, which gives me 25. And what you'll notice is, if I have a triangle that has a side of 3, a side of 4, and a side of 5, then the squares of those numbers add up to equal each other. And this is a right angle, by the way. So if you'll see, 3 squared, this one, plus 4 squared, this one, if I add those up, I get 25, which is this one squared. So the Pythagorean theorem states, in any right triangle, with legs of lengths A and B and a hypotenuse with length C, A squared plus B squared equals C squared. So I'm going to write that out here. This is our Pythagorean theorem. A squared plus B squared equals C squared, where A and B are your legs and C is your hypotenuse. All right. Now, the converse of that is also true. If a triangle has a side lengths of A, B, and C, and A squared plus B squared equals C squared, then the triangle is a right triangle. So there's a couple ways to look at that. If you know the triangle is a right triangle, then I can find a side by using A squared plus B squared equals C squared, where these are the legs, C is the hypotenuse. Or if they tell me the lengths of the sides of a triangle, and they tell me that this is a true statement, that A squared plus B squared equals C squared is using those side lengths, then I can tell you then it is a right triangle. So that's the Pythagorean theorem and its converse. Let's go ahead and do some example problems where we can find missing sides. All right, it says find the missing side length for each right triangle. Round to the nearest tenth. So we're given these two sides. Here's my right angle, so I know this side is my hypotenuse side, so that's going to be my C side. It's always a good idea to label which one's your C side. Once you've got your C side labeled, it doesn't matter which one you make your A and your B. It'll still, since we're going to square them and add them together, I can make either one of these my A and my B. But your C side, you have to make sure that that's the hypotenuse of that triangle. All right, so since it is a right triangle, then we need to plug in these numbers to the formula A squared plus B squared equals C squared to find our missing side. So we're going to be finding our C side this time. So 4 squared plus 8 squared equals C squared. And our goal is then to solve for C. So 4 squared is 4 times 4, so that gives me 16. 8 squared is 8 times 8, so that gives me 64. Add those two together, and we get 80. And then we need to get C by itself. Since it has a square on it, to get rid of that square, you do the opposite of squaring, which is taking the square root. So in your calculator, you would find the square root of 80. And we get 8.94. Now they want us to round to the nearest tenth, so that's to 1 decimal place. So it'll be 8.9. Since that 4 is less than 5, the 9 just stays a 9. So that's number 1. Number 2, first step, find your C side, label it. Then the other 2, just label A and B. It does not matter which one of those. Plug in and solve. So we've got 6 squared plus 3 squared equals C squared. Goal again this time is to find C. 6 squared, 6 times 6 gives me 36. 3 squared, 3 times 3 gives me 9. Add those 2 together and we get 45. And then to get C by itself, we need to take the square root of both sides. Square root of 45 in your calculator. And if you're having trouble finding the square root on your calculator, you'll see it on here, it's the little blue square root on the x squared button. So since it's blue, you got to hit the blue button first, then hit the x squared button, and you'll get your square root. And then you just type in what number you're trying to take the square root of and hit enter. So we get 6.70, so that'll end up being 6.7. Number 3, we didn't leave me a whole lot of space here to work this out. Label your C side, then A and B. So 3 squared plus 7 squared equals C squared. Again, we're finding C. So that gives me 9 plus 49 equals C squared. 9 plus 49 gives me 58. Last step, to get C by itself, take the square root of both sides. C equals square root of 58. Second, in the x squared button, 58, enter, you get 7.61, so that would be 7.6. Number 4, this is my C side, so A and B, 2 squared plus 6 squared equaling C squared. 4 plus 36 gives me C squared, so that's 40. Got to get C by itself, so we take the square root. And if I go too fast, just pause the video, catch up, and then continue on. Square root of 40, 6.3 when you round to the nearest tenth. Alright, so on all of those, we end up having to solve for C side. Down here, I think it's going to end up being an A or a B side for all of these, so we get a little bit of practice with both. So we know our C side. So again, it doesn't matter whether you call it A or B, either one. I'm going to call the side that we don't know A and the side B. Still plugging everything into that A squared plus B squared equals C squared. So we've got A squared, because I'm trying to find my A, plus 3.6 squared equal to 7.4 squared. So you type into the calculator 3.6 and then hit that x squared button to do the square and enter. We get 12.96 equal to 7.4 squared. So 7.4, hit the x squared button, enter. We get 54.76. All right, now to get a squared by itself, since I have it on, I have to get that by itself on this side. So I need, since I have plus 12.96, I need to do the inverse and subtract 12.96, and whatever I do to one side, I got to do it to both. When I do that, the 12.96's drop out on this side. 54.76 minus 12.96 gives me 41.8. Then last but not least, a squared is by itself, but I need to get a by itself, so I got to get rid of that square. So do the inverse and take the square root of both sides. So we get a equals, hit the second button, then the x squared, and we're typing in 41.8. Enter, and we get 6.46. So that 6 on the next to the 4 means we need to bump that 4 up 1. So it's going to be 6.5. So the A side is 6.5. Figure out which side's your C side, the opposite of the 90-degree angle, so your hypotenuse. You can call these A or B. I could have called that B and that A. It does not matter. I'll still end up with the same answer. Setting it into our equation of A squared plus B squared equals C squared. I got A squared plus 9.7 squared equals 13.3 squared. So I need to bring down my A squared because we don't know what that is. 9.7 squared gives me 94.09. And 13.3 squared gives me 176.89. And now again, I'm working towards getting that A squared by itself. So since I have plus 94.09, I need to subtract 94.09. Whatever I do to one side, got to do to the other. So 176.89 minus 94.09, and we get 82.8. And then to get that A by itself, got to get rid of the square, so we do the inverse and take the square root. So that leaves me A equals square root of 82.8 gives me 9.09. So that ends up being 9.1 when you round to the nearest tenth. Now, you may be questioning, whenever I've been taught in the past, if I take the square root of a number, then I actually get two numbers. I could have positive 9.1 or I could have negative 9.1. Well, since we're talking about lengths of the sides of a triangle, we cannot have a negative length, so we just always go with the positive answer. So in case you were wondering about that. Number 7, this is my hypotenuse side, so that's my C side. A, B. So 6.5 squared plus B squared equals 9.9 squared. 6.5 squared gives me 42.25. Bring down your plus B squared, because we don't know what that is yet. And then 9.9 squared gives me 98.01. And then it's all about getting that B squared by itself. Since this is a positive 42.25, we need to subtract 42.25. Whatever you do to one side, you got to do to the other. So that leaves me B squared equals 98.01 minus 42.25 gives me 55.76. And then last but not least, take the square root. That is a common mistake that people make. They forget, they get to this point and they think they're done. Always make sure if you've got your B squared or your A squared or your C squared, you got to take the square root of it to get B by itself. So the square root of 55.76 gives me 7.46. So that will end up rounding to 7.5. Last but not least, we got 3.9 squared plus B squared equal to 11 squared. 3.9 squared gives me 15.21. Bring down our B squared since we don't know what that is. 11 squared gives me 121. And then it's all about getting the B by itself. So subtract 15.21. That leaves me B squared equals 105.79. And last but not least, take the square root. You get 10.28, so that rounds to 10.3. Alright, again, if you missed anything or I went too fast, pause, rewind, do what you got to do to get all your notes. Moving on to the next page is some practice. So it says, use the Pythagorean theorem to find the missing side length. So same thing of what we just did. They gave you the formula, they gave you the sides. The side we're trying to find is our C side. So find that C side first. Actually, yeah, that's what they're asking. And then they want us to find the area. So it's two problems in this first one here. So find your C side using your formula. So I'm going to call this my A side, this my B side. So we've got 7.5 squared plus 4 squared equals C squared. 7.5 squared gives me 56.25. 4 squared gives me 16. Add those together, and we get 72.25. And then last but not least, take the square root of both sides.
Would Stacy Afori come to the office, please? Stacy Afori to the office.
And then that gives me 8.5 exactly for my C side. All right, so my hypotenuse side is 8.5. Now, they're asking down here for the area of a triangle. So in case you don't remember, the area of a triangle is 1/2 times the base times the height of a triangle. And the base and height of a triangle make a 90-degree angle where they meet. So we can call one of these the base and one the height. It does not matter which. We're going to end up using both anyway. So 1/2 times 4 times 7.5. So if you can put 1/2 in parentheses, 1 divided by 2 inside the parentheses, and then take that times 4 and times 7.5. Or if you thought of 1/2 as just being 0.5, you could have just did 0.5 times 4 times 7.5, either way. And we get 15 total. So the area of the triangle is 15 units squared. Whenever you're talking about area, it's always units squared. If they had told me they were centimeters or inches, then I would have said centimeter squared or inches squared, but they didn't tell me that what these units were. So we just say units squared. All right, same kind of problem on the next one, but this time instead of finding our C side, we're finding either A or B, however you want to do it. I'm going to label the missing side as B. So I've got 5 squared plus B squared equals 13 squared. 5 times 5 gives me 25. Bring down my B squared because I don't know what that is yet. 13 squared gives me 169. And then it's all about getting the B squared by itself. So subtract 25. We get B squared equals 144. And then take the square root of both sides to find out B. And B equals 12. Now that we found the missing side, the next question is find the area. Area of a triangle equaling 1/2 times base times height. Or you could take base times height and divide by 2. Gives you the same answer. So that's 1/2 times, now remember our base and height have to make a 90-degree angle, so it has to be the 2 legs of this triangle. So 12 and 5. One half times 12 is 6. 6 times 5 gives me 30. So 30 units squared. The next question tells me the area of a square is 225 square units. Now something that we know about squares is their sides are all equal. And they all make 90-degree angles where they meet. So the area of a square, the way you find the area of a square is length times width. Now, if the length and width are the same length, then it's just length times length or side times side, however you want to think of it. So I always think of this is more like a rectangle, length times width. With a square, they like to use side and side because all the sides are equal, so they use the same variable. So the area of a square equals side times side, or side squared. So if they tell me the area is 225, I replace the A that represents area with 225, and then I can find the side length by getting that S by itself. It's S squared, so we just take the square root. So the square root of 225 is 15, so the side lengths are 15 units, which was the answer to question A. Part B asks, well, what's the perimeter? Remember, perimeter is just adding up all the sides. So if each side is 15, 15 plus 15 plus 15 plus 15 gives me 60. And we're talking units because they didn't tell me if they were inches, centimeters, feet, miles. They didn't tell me any of that. So 60 units. And then they want to know the length of its diagonal. Oh, good question. So if I draw a diagonal on there, then I've actually got a right triangle where two of my sides are 15. And I got to come up with this C side. So all I did was take this triangle here and redraw it down there. So now I can use the Pythagorean theorem to find the length of that diagonal. So that's my C side that I'm trying to find. So I can make this my A, this my B. And so we get 15 squared plus 15 squared equals C squared. And then we just solve. So we know 15 squared is 225 plus another 15 squared is another 225. Add those together, we get 450. And last but not least, take the square root of both sides to get that C side by itself. So when I do that, I end up with a decimal. We'll go ahead and round to the nearest tenth. The decimal is 21.21, so that gives me 21.2 if I round to the nearest tenth. And that's just units, because it's not area, it's just the length of the diagonal. All right, number 4. A circle has a circumference of 14 pi. Now the area for circumference is C equals 2 pi r. Okay? They want to know, for part A, what's the radius? So if they tell me the circumference is 14 pi, I replace C with 14 pi. Bring everything else down. And then it's all about trying to get that radius by itself, that r by itself. So since this is 2 times pi times r, the inverse of multiplication is division. So I'm going to divide both sides by 2 pi. And what I do is 14 divided by 2 gives me 7. Pi divided by pi cancel each other out. And my 2's and my pi's cancel each other over here, so I'm just left with my r. So now I've got my r by itself, and it's just r equals 7. So the radius is 7 units. Next, they ask for the area. Area of a circle equals pi r squared. Now that we know what the radius is, we can replace r with 7. 7 squared is just 7 times 7, so that gives me 49, and then we've got our pi on there still. That's the most exact way to answer that question. You could replace pi with 3.14, but then you're getting a rounded answer. I prefer an exact answer, so let's keep it as 49 pi. And area is units squared. I didn't write it in there, but that's what that would be. Number 5 says AB, side AB is the diameter of the circle at the right. Find the length of side AB. All right, so something we've learned in our past here. When you have the diameter of a circle, that means it's passing through the center of the circle. So this arc here is 180 degrees because that's half of a circle. So that means here's its inscribed angle to go with that arc. So it's always half of whatever that arc is. So half of 180 gives me that 90 degrees. So I know that's a 90-degree angle because this side is a diameter. So since that's a 90-degree angle, now I know I'm working with a right triangle, and we're trying to find the hypotenuse side of that right triangle. So I know my two legs, so I know my A side, I know my B side, I got to find my C side. So we're using the Pythagorean theorem on that. So we've got 8 squared plus 6 squared equals C squared, and C is the side we're trying to find. 8 squared gives me 64. 6 squared gives me 36. When I add those together, I get 100. To get C by itself, square root. Square root of 100 is 10. Now that C side is the AB side. So side AB equals 10. Next, they want to know what's the radius. Well, if we know the diameter of the circle is 10, then the radius is going to be half of that. So radius equals 10 divided by 2, which gives me 5 units. Last but not least, they want to know the area. Remember, area of a circle is pi r squared. Replace the r with 5 because we just found out that the radius was 5. 5 squared gives me 25, so my answer is the area is 25 pi units squared. Area is always units squared, in case you're wondering. Alright, again, if I go too fast, pause, rewind, do what you got to do to get all these notes and all this practice. But now we're moving on to word problems. So that means you're going to end up drawing your own diagrams to go with these. So number 1 says, the bottom of a ladder must be placed 3 feet from the wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? So I'm working with a triangle here. And of course, since we're working with Pythagorean theorem, we're working with a right triangle. So here is my wall. Here's the ground, and this is my ladder. Remember, when we climb a ladder, it's always leaning. So they said the bottom of the ladder, so here's the bottom, here's the top, bottom's on the ground. So they said the bottom of the ladder must be placed 3 feet from the wall. So that tells you this side of this triangle is 3 feet. Says the ladder is 12 feet long, so the ladder side is 12 feet. And they want to know how far above the ground does the ladder touch the wall. So they want to know this distance here, so this side. That's what we got to find. Okay, so we've got a right triangle here because where the ground meets the wall is always a 90-degree angle. And find your C side. Label your other sides, your A and your B side, and then use the Pythagorean theorem to find your missing side. So the side I'm missing, the way I labeled it, is my A side. So it's A squared plus B squared, which is 3. So 3 squared is equal to C squared, which was 12. So 12 squared. I'll put that formula up here again. And you'll hear me say it a billion times over this year. A squared plus B squared equals C squared. All right. So A squared plus 9 equals 144. All about getting that A by itself now, so subtract 9 from both sides. A squared equals 135. And then last but not least, take the square root. And let's round to the nearest tenth. When I round to the nearest tenth, I get 11.6. Now this time they did tell me the units. The units are in feet. So we attach feet to our answer. You cannot do these problems without drawing the diagram. So always draw your diagram, label everything. Number 2, a soccer field is a rectangle, 90 meters wide and 120 meters long. So I'm going to go ahead and draw my rectangle. It says it's 90 meters wide and 120 meters tall. I drew those backwards. Either way, it'll still work. 90 would be the shorter side, 120 would be the longer side. The coach asks players to run from one corner to the other corner diagonally across the field. How far did the players run? So that's the side we're trying to find. Here, since we're talking rectangles, we know these are right angles. So I have a right triangle here. And the side we have to find is our hypotenuse side of that right triangle. So that's C side. So I'm going to call this A, this B. Let's solve for it. 90 squared plus 120 squared gives me C squared. And we're getting bigger numbers this time. 90 squared is 8,100. 120 squared gives me 14,400. Add those together, we get 22,500. And then last but not least, take the square root. I get 150 equals C. Now, they gave us the units, so it's 150 meters. Number 3, how far from the base of the house do you need to place a 15-foot ladder? There's a lot of ladder questions. They like ladder questions for these kind of problems. How far from the base of the house? So here's my house. Here's my ladder. Here's the ground. So they want to know how far from the base of the house, so that's the bottom of the house, do you need to place a 15-foot ladder? So our ladder is 15 feet. That's what that little, like, exclamation point, or not exclamation point. I need a nap. That's what that little symbol means. That stands for 15 feet. Sorry. How far from the base of the house do you need to place a 15-foot ladder so that it exactly reaches the top of the 12-foot wall? So the 12-foot wall of my house, so we know this is 12 feet. And what they're wanting to know is how far from the base of the house do we need to place the ladder, the bottom of the ladder. So this is the side we're trying to find. All right. This is my hypotenuse side, so we know our C side. I'm going to call that side A, and the side I'm trying to find B. So we've got 12 squared plus B squared equals, 15 squared. So 12 squared gives me 144. Don't know my B, so bring down the B squared. 15 squared gives me 225. And then we got to work towards getting those B's by themselves. So minus 144. So we get B squared equals 81. Take the square root of both sides, and we get B equals 9. Now, they used feet in all of these, so you can write feet as your unit. And if you felt like writing it the way they did like that, I would accept that as well. All right, number 4, what is the length of the diagonal of a 10 centimeter by 15 centimeter rectangle? So we got our rectangle. I'll try to mark it right. The longer side is 15 centimeters. The shorter side is 10 centimeters. Obviously not drawn to scale. And we're trying to find the length of the diagonal. So that's my C side that I'm trying to find. I can call this A, this B. Plug them into the Pythagorean theorem. So we got A squared plus B squared equals C squared. So that's 15 squared plus 10 squared equals C squared. 15 squared is 225. 10 squared is 100. Add them together, we get 325. Take the square root of both sides. And I get 18.03, so I'm going to put it as 18.0. The reason I'm not just putting it as 18 is because if I just put 18, they're going to think that that was exactly 18, the square root of 325 being exactly 18. By putting that 0.0, you're making a statement that we had to round to get that, and so it's not exact. And this was in centimeters. So that diagonal of that rectangle is 18 centimeters. Number 5, the diagonal of a rectangle is 25 inches. So this time they're telling us the diagonal. They're telling us the width, and then they want us to find the area. Ooh, that's a good one. All right, so draw your rectangle. They say the diagonal is 25. They tell me the width is 15. And they want to know the area. Well, to be able to find area, we got to do length times width. So area of a rectangle is length times width. We only know the width, we don't know the length. So that's what we got to find first using Pythagorean theorem. So the diagonal is my C side. I'll call that my A side, this my B side. So first you got to find that. So a squared plus b squared equals c squared. So that's a squared plus 15 squared equals 25 squared. 15 squared gives me 225. Bring down your a squared, bring down your 225. And 25 squared, that's going to give me a big number. It gives me 625. So now we got to get that a squared by itself. Subtract 225 from both sides. We get a squared equals 400. Take the square root of both sides. And we get a equals 20. So, and this was in inches. Everything was in inches. So this a side is 20 inches, is what we figured out, but that wasn't the final question. The final question asks, what is the area of the triangle? So since the area equals length times width, it's going to give us 20 times 15. When I multiply those together, I get 300. And since it's area, it's inches squared. Our unit was inches, area is inches squared. And the reason it's inches squared is because when we take length of 20 inches times width of 15 inches, when I multiply the numbers, I get 300. When I multiply inch times inch, that's inches squared. So that's why we have those units. All right, moving on. Oh, it's closure time. So your closure is these 4 problems. When you get done with that, do the homework, which is a mixed review, squares and rectangles. And then on the back is triangles and Pythagorean theorem. So do all of that, and then when you complete the package, turn it into the sub. If you complete it today, awesome, turn it into sub today. If you don't quite get it finished because you got all the homework you still got to do, then take it home, finish up the whole packet, and then bring it back and return it in the next class. And I will see you soon.